Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, in this video, I will discuss this inverter AC board. It is 2-ton inverter based board. Any company, any capacity, any size does not matter. The basic phenomena will remain same if it is single phase or if it is 3-phase. We have to take AC voltage. We have to process through EMI filter, RFI filter, different protections for high frequency, for high voltage, for high current, electromagnetic inductions. After that, after purification, we transfer this AC voltage to bridge rectifier. This bridge rectifier will rectify this AC voltage into DC voltage. Then we have a regulator. What is that? That is power factor correction. It consists of IGBTs, rectifier diodes, reactor or PFC chokes, and then we have DC rail. We have 680 microfarad, 450 volt, 3 capacitors that are in parallels. So this capacitor bank stores the electrical charge for further consumption, for further switching. Then we have a low voltage power supply section. This power supply section is used to drive the inverter. We use these voltage to switch, but to activate the circuit, to activate the ICs, processor and different small ICs which are installed here to control, to make switching, to drive these IGBT modules, IPM intelligent power modules. So these ICs require power. The required power is produced from this low voltage power supply section. Then we have some other relay section. These are used to drive some valves, some heaters, some cooling fans, and then we have the most important part, that is IPM. This is intelligent power module. It takes this DC voltage and it receives a switching commands, pulses that are very weak pulses, but these pulses are converted into high voltage, or we can say these high voltage are switched based on the drive signals. So the drive signal will switch these pulses and it will make 3-phase voltage, and we provide these voltage UVW, blue, yellow and red wire, to the compressor. And the same, a small IGBT is here. It is used to drive the cooling fan. Then we monitor different sensors, different inputs for temperature, for compressors, for ambient temperature, for coolant temperature, like that. And all inputs are provided to the processor to monitor the function of the complete unit. And based on the drive signals, the current consumptions, the voltage value, this processor will ensure all the proper function, smooth line operation for all the system. If there is any malfunction, if there is any problem in the board, so this will decide what to do. Either the problem is dangerous for the system, then it will cut the drive for this IGBT module and it will communicate through these line drivers, serial communication port, with indoor unit. It receives the commands from indoor unit and finally it will transmit the status of the board, status of the complete circuit to the indoor unit. In series of these videos, I will not explain complete board in one video because it is too much lengthy. I will start from input side and we will discuss every single component and its function and its problems. If we are using 3 components here, why these are 3? If we are using this capacitor, why this capacitor is here? So let's start. When I received this board, its 2 IGBTs were damaged and it's this fuse, 30 ampere fuse, glass fuse was broken. So I removed this fuse and I removed these IGBTs and heatsink, made it clear for presentation, for best understanding. So let's start. Here we have 3 wires. The 4th wire is communication. So communication wire we will discuss when we will start the communication step. So at that time we will start it. Any board, if it is any capacity, any size, if it is for refrigerator, if it is for freezer, either it is for sewing machine, needle positioner board, all of these are approximately the same. The power rail and everything is same, just we give some input and we take some output. So let's start from this point. At this point I have fuse from this point to this point. This is our fuse. So I removed fuse, but I will connect a jumper for a while so that we can continue the circuit. Never connect a jumper in place of fuse. So it is just for demonstration. It is not a permanent solution. Always install correct value fuse from line to this point. This is line voltage. Now in the line we have 1 point, 2 point, 3, 4 and 5th is fuse. So let's discuss everything here. The first, that is this main capacitor, 2.2 microfarad, 270 volt X2 capacitor. This is class X capacitor. It is connected between line and neutral. So we say this one is line, neutral. So between line we have 30 ampere fuse. After that we have class X capacitor, that is 2.2 microfarad, 275 volts. So this is our neutral line. So this line is neutral. I will give a black color to the neutral line. So in the neutral line we have 1 point for this capacitor which we discussed, the main box capacitor, X2 capacitor, and then we have this point. We have one component here, one terminal here, one terminal here. Let's check it. So it is MYN15 621 km. It is varistor, metal oxide voltage arrestor, metal oxide varistor. So this component is connected directly between line voltage and neutral line, because this line is neutral. So this line is line voltage and here we have neutral. So this component is connected directly in parallel to the, it is varistor at 385 volt RMS, high voltage spike. At high voltage it will become short. Sorry, we did not discuss this X2 capacitor class X. At high frequency, at 275 volt, the excessive spikes, frequency spikes, will bypassed from this point. If it will receive more repetitions of frequency or frequency spikes, it will become short. When it will become short, it will make a short circuit between neutral and line, and in that case it will cause to flow heavy current. So this fuse will blow away, line fuse will disconnect it, our next circuit will protect it. The same is here. Here is high frequency, here is high voltage. So this component will connected here. It is connected between line and neutral. At high voltage, more than 385 volt, it will become short internally. When it will become short circuit internally, so in that case the current flow will in this path and fuse will burn out. Next circuit will protect it. In the same point, one point is here, second point, so it is the same MOV, but this configuration, it is connected between line and neutral. But see this one, it is connected to line, and then this point, then this point. We have the same, we have same two MOVs, varistors, RV3 and RV2. So these are connected in series, this point, this point, this and this. But here is some change. The same value, it is connected between line and neutral. The same value is connected between line and the other MOV, then the neutral. But if we look here, we have another node here, another component here. We will see it. What is that? It is the center point of the both MOVs. Here we have EPCOS EM3600. It is surge arrestor. So it is connected between PE, power earth, power ground, this wire. If you look in this place, we have two other capacitors that are class X capacitors between this inductor and this capacitor. It is connected between this capacitor, this point, this point, this point. So these two capacitors are in series, but the common point of both is connected to this ground line, this earth line. So earth line is connected here and earth line is connected in this point also. But the central point, common point, is connected to this earth line. Then we have this inductor, dual line filter. It have two coils. One coil, it is connected between line, and the second coil is connected between the neutral. It is 5 millihenry, 20 ampere. It is our first stage filter. This inductor and this capacitor will work together and high frequency spike will eliminated here. Then we have high voltage. If the high voltage are present in the line and neutral, this varistor will become short circuit and it will make a short circuit and it will damage this fuse. High voltage spike in any one line or neutral, it will reach here at this MOV. After that, it will allow to this surge arrestor to remove this spike, high voltage spike. If it is in neutral, so it will remove from this point. So line from this point and neutral from this point. If it is in line and neutral, then it will pass from here. And if we have high frequency spike, if this was in high voltage case, if we have in high frequency case and it is just only in single line or single neutral, in that case, that is called common mode noise. So that will removed to the ground. Earthing wire must be connected. It is for equipment safety, it is for personal safety. After passing this filter, we have three capacitors here. 1, 2, 3. line reached here, neutral is here, and we have 3 capacitors at this point. The box capacitor, it is connected from this point to this point, but the small class X capacitors are connected in the same way, from neutral to earth and from phase to earth. So I will connect other 2 capacitors here. The common point of both capacitors is connected to this. Then we have another dual line filter. From this point to this point we have neutral line here, and after filter we have another capacitor C110 C31. From this point our neutral will pass from this point to inner side of the print, and it is reaching at this bridge rectifier. It is reaching bridge rectifier AC terminal. So this line is now clear. So we have to follow this line. Now our line voltage are reached here. At this point we have 2 components. We will discuss this line later, because this time we will continue to the line voltage. So in the line voltage we have, now it is very interesting point. At this point we have one component here, one connection, and the second connection. If we see this component here, it is PTC, positive temperature coefficient resistor, and then its output will come here at this point, and we have another PTC at this point. Then it will reach here to this troubleshooting jumper. Then we are reaching here. Current will flow from this point to this point, then in this way, and here. But now if we check here, we have another relay sign from this point to this point. Relay sign. So that means there is something here. If current is passing through this, and at that time, at that moment, if this relay will turn on, so it will bypass all these components. So let's check it. First of all, I will remove this PTC. So here we have, it is MZ47R. This is 47 ohm PTC, positive temperature coefficient resistor. We will check its resistance. It is 44.9 ohm because its resistance depends on the temperature value. This time my workshop temperature is down, so it is giving 45. When the temperature will increase, its resistance will increase. Positive degree centigrade or positive T, it is written here. And then we, as I discussed, from this point to this point, and then we have another PTC. So we have 2 PTCs in the series. Now we will discuss the relays, and then we will discuss its function, why it is used here and why the relay is used here. So if this relay will turn on, so it will bypass all these 2 components. So here I will make a relay, and if this relay will turn on, if this relay is on, in that case this PTC will bypass. This PTC will bypass. Now the current is passing from this point. In that case This will bypass the second PTC. This is K2, K1. We will consider this point number 1, point number 2. Now bring power point number 1 and 2 here. This PTC is here and we have 47 ohm. If this relay is off, so our line current, line voltage will pass from this PTC, and then it will go to the output side. And our circuit will face 94 ohm resistance, series resistance from this point to this point. If this relay will turn on, at that time our current will pass from this PTC and to this PTC. Sorry, this PTC relay, and because this is 47 ohm and this is bypass, so the current will pass from the bypass area. And if this relay is turned on, in that case the current will pass through this area, because now it will not go to 94 ohm resistance. It will, current always takes easiest path. As I discussed, we have 3 big capacitors, large amount of capacitors, and these are in parallel. So it is about around 2000 microfarad. That is very huge amount. And if we apply voltage here, so these capacitors will try to draw maximum current. So when this circuit will make a surge in high current, at that time might be something will damage. To protect a damage due to heavy current flow in the DC rail, the first of all, these 2 relays will remain off. So current will forced to move both PTCs, positive temperature coefficient resistors. So these capacitors will start charging. We will discuss it later, but just I am giving concept for working of these components. At first attempt, both PTCs are in series. So our current flow will from this point to this section, and then from here to here, then here, and this voltage will reach and bridge this component. Normally this is working path in the starter phase. In the first attempt it will pass in this way, then this second PTC will bypass and the current will pass from this point to this relay and here. When our second relay K2 will turn on, at that time the line voltage is directed directly to the bridge rectifier, so it will allow to charge these capacitors linearly. It will protect a surge. This network will protect a surge current, and if in any case there is a short circuit, there is heavy current flow in the board, so it will disconnect this bypass. In that case the current will route it through these PTCs and circuit will try to draw current. The internal resistance of these PTCs will increase, so these will stop the current. And if internal temperature, it have internally a metal oxide disc, if internal temperature increases, this disc damage inside, so it will break the path totally. So it will protect the circuit from overcurrent. So here we have bridge rectifier. Now we have to see some other lines. If you come to this point, at this area, in this area we have this fuse. It is a second fuse, T2. That is after PTCs at this point, F2, that is 3.15 ampere, and it will reach. This fuse is used to apply voltage at this relay section. In this relay section we have two-way valve, four-way valve, heater for the compressor, fans. So we have these relays here. At this time it is using only just one relay, that is heat and cool. What will happen? When we press a heat mode switch on our remote, we shift the system in heat mode. At that time a command from processor will generate it from indoor unit to this processor, and this processor will generate to this ULS2003 IC, and it will drive the coil, and in that time these voltage, line voltage, will switched through this relay, and it will go to four-way valve to swap the valve in heat mode. So this is line voltage function from this fuse. And in the same time this line is also coming to this node. At this point, this area, we have NTC, negative temperature coefficient resistance. This is after fuse. So this line is going to relays common terminal, but in this point from this section it is going to NTC, and this NTC, 16 ohm NTC, negative temperature coefficient resistance 15.6, it is 16 ohm NTC. One end is connected to fuse, the second end is connected to this diode. Here we have D3, D49, D14 and D4 and D14. We have 1, 2, 3, 4. We have 4 diodes here. It is bridge rectifier, and if you see this point, this line, it is reaching here, it is neutral. So neutral line, as I discussed, that we will discuss it later. Now it is the time to discuss this line. This neutral area will reach here at this capacitor, and our positive line is connected through this NTC to this bridge rectifier to rectify the voltage and charge this capacitor. So we can say this line, it is coming here. We will discuss this block later in our next session. Low voltage power supply. Let's see the diagram again. Line and neutral, fuse, high frequency spike removal capacitor 2.2 microfarad, high voltage protection. This for line or neutral. Anyone becomes unbalanced and it takes high voltage, so it will remove this voltage surge to this surge arrestor, and it will remove to ground. For common mode noises, this inductor for energy storage and first stage filter. Then we have second stage filter. After that we have this current surge protector. 2 PTCs, positive temperature coefficient resistors, are here. Then we have bypass relays here. Where are that? One relay is here, the second relay is here. So K2 and K1 relays, and these will protect from high surge. Then this line is reaching here at the bridge rectifier, and bridge rectifier output, we will discuss this section later on. We have another fuse. This fused voltage will reach to relay common terminal for different operations. We will discuss this section separately. And we receive voltage to NTC, and NTC will provide voltage to low voltage power supply, and we have common line connected to low voltage power supply. So let's discuss. Practically we will see the troubleshooting. To troubleshoot this board, first of all we will connect this point and we will check fuse. Fuse is working. If we cannot find the continuity here, that means the fuse is bad. Then check between the neutral line. We have 30.7K. So this resistance is low resistance and its resistance is increasing. So that means it is charging some capacitors. So this is not a good indication. It must be in 100 kilo ohms, hundreds, 500, 600, 1 mega and above. Swap the leads. So this resistance started from low side to upside. That means we have something wrong in the board. So this resistance, input resistance, must be high. So this resistance, this indication is not good. Now from this point, when we reach here, okay, PTC input side, output side, that is good. In AC input terminal, and check in this line area. So we are taking 89 ohm resistance. So this 89 ohm resistance from this first PTC and this second PTC, and this neutral line, this area is directly connected to this neutral. So we have one line with 0 ohm resistance and the second line with 88 ohm, that is due to these PTCs. Then one relay will close. At that time its resistance will decrease to 45 ohm, 47 ohm. When the main bypass relay will turn on, at that time we will receive 0 ohm. But at that time the capacitor will charge and we cannot check the resistance. So function wise it is working like this. Our input resistance is varying. That means something wrong in the board. We can check the bridge rectifier. Set multimeter to diode mode. Connect black lead to the common. And here we have a cut on the bridge that is at the positive output terminal. So connect black lead in the positive terminal and connect red lead to input AC input terminal. It is giving short circuit, 0 ohm resistance. So bridge rectifier is short internally. So this terminal is giving 0.4 ohm resistance. So this terminal is short. Now connect it second negative terminal, this end, connect with AC terminal, so it is short. So pair of this bridge rectifier is shorted internally, so that means this bridge is wrong. So this was the reason we were taking this input resistance here. We were taking this low input resistance. So this low input resistance due to this bridge rectifier. So we can remove it, we can test it, we can replace it. Why this damaged? Because we have two IGBTs damaged here, which caused to damage this bridge rectifier and which caused to damage this fuse. And we will continue to live testing in our next session, and we will continue PFC circuit, bridge rectifier circuit and other circuits in parts. So friends, I hope so this video is informative. If it is informative, give a thumb up. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.